Hello everyone and welcome back. Today we are diving into something really exciting. New experimental model from Google's research called Gemini Diffusion. Now I know what you're thinking. Another AI model, but this one is different. Google is exploring a new way to generate text and code using a technique called diffusion. Look at that. The most striking feature of Gemini Diffusion is its incredible speed. It generates content significantly faster than even Google's fastest current models, like Gemini 2.5 Flashlight. We are talking about a massive leap in inference speed. By the way, if you want to learn what diffusion models are and how they work, here is my video about it. Now, you might be wondering, what's the catch? While Gemini Diffusion is blazingly fast, it's not designed to produce the absolute best quality code, at least not yet. It probably won't outperform the top tier autoregressive models like Gemini 2.5 Pro. So where do diffusion models like Gemini Diffusion fit in? This is where it gets interesting. The key is the concept of good enough. So look at this chart. Right now, in 2025, for most developers, code quality is a top priority, much more important than inference speed. The existing top-tier models are designed to provide higher quality, even if the inference speed is around 60 tokens per second. Basically, no one cares if the response meets your needs, and that's okay. I also prefer to wait few more minutes for code that will run without errors on the first try, rather than get code faster and spend more time debugging it. But let's fast forward to 2030. Both diffusion and autoregressive models will have improved significantly. At some point, for a lot of common tasks, both types of models will be good enough. When the code quality is perfectly acceptable from multiple providers, speed becomes the deciding factor for user preferences. Think about it like this. If you can get a solid working piece of code in a fraction of the time, that's a huge win for productivity. This is where diffusion models will shine. Their speed will make them the preferred choice for a whole range of tasks. So what are the good enough use cases? First, for example, will be all product one-pagers. Second can be a code refactoring. Basically, all those tasks that can be time-consuming but don't necessarily require top-tier logic, like generating boiler code, writing unit tests, and even documenting code. We are seeing a lot of innovative companies building tools that leverage AI for simple development. Companies like Lovable, which can generate a simple web application in seconds from natural language. And there is Replit, which in the same way is transforming ideas into apps. And of course, there is also a Google solution for this problem, the Firebase platform. It is a key part of this ecosystem. This creates a powerful end-to-end development environment. So, what gives Google an advantage? They have a vast amount of data to train those models, more than enough money to fund the research, a great existing infrastructure, an enormous user base to test on, and the brilliant minds to build it all. So, what does all this give Google? How can they use this massive leverage? They have a lot of resources, so they can easily explore both ways. They can train diffusion and autoregressive models at the same time. They can let people experiment with both for free, which they basically do through AI Studio. This allows them to test user preferences and, most importantly, determine the good enough threshold for different developers and tasks. By simply understanding where users are willing to trade perfection for a massive speed boost, Google can tailor its AI offering to fit much wider range of users' needs. This will ultimately allow them to capture a larger share of the developer market. So, what do you think about this trade-off between code quality and inference speed? Let me know in the comments below. And if you enjoyed this video, don't forget to like and subscribe. And thank you for watching. See you in the next one.